Hi, this is Miss Cairo. In this lesson, we're working on lesson 2-3, which is unit 2, lesson 3. And in today's lesson, we are going to do two things. We're going to be visualizing mm, decimals using models, and we're also going to be comparing fractions. So for this lesson, you do need materials, and the materials are your activity book, your place value chart with your expo marker, and your secret code cards. So hopefully they're in a little baggie, so go ahead and grab those. And once you have all your materials, go ahead and open up to page 43 in your activity book. And please find this page that I have on my screen. So we're going to be working mostly in page 43, and then we're going to preview page 44, and you're going to continue the rest with your teachers. So I will get us started off. Let's go ahead and point to the red triangle that's next to the heading on page 43 with me. And go ahead and read along with me. It says visualize with other models. Basically what we are going to be doing on this page, we're going to be visualizing what decimals look like using fraction bars, using grids, and using number lines. Okay, so number 1 says the bar below represents 1 whole or 1. So take a look at the bar graph, and then part A says shade 6/10 and then shade 2/100. So what I'd like you to do is I'd like you to circle those important directions. Please circle 6/10 and then circle 2/100. So we're going to be doing some shading here. Take a look at this bar graph and take a look on how it is split up. Okay. What I'd like you to do first, let's look at these darker um, these darker like separations, I guess I would call them. How many of the darker, maybe I'll just call these a bar. How many of the darker bars are there within this bar graph? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I see with the darker bars that this one whole is split up into 10 pieces. And then how many pieces are within, for example, this first piece from the start to that darker bar? How many little pieces are there? Go ahead and count. How many pieces? Count in your book. How many did you get? Did you get 10? Yeah. So then with the more like faint lines, then we can see using these little fainter of lines that this one hole's also split up into 100 pieces. So let's use that information to shade. So let's start off with 6/10. How do I shade 6/10? In 6/10, we were practicing this in a previous lesson. 6/10 written out in fraction form is this. And how do we write out 6/10 in decimal form? How do we write out 6/10 in fraction form? 6 as our numerator and 10 as our denominator. And we've practiced a lot with this. If there's 10 total pieces and I want to shade in 6 of them, that will represent 6/10. So what we're going to do is we're going to start in the beginning, and I can just quickly shade in. It doesn't have to be perfect. There's 1/10 shaded in. There's 2/10 shaded in. How many are we shading in? 6. Keep going. 3, 4, 5, and 6/10 are now shaded in. 6/10 out of a total of 10/10. Great. So we got that done. Let's look at the 2/100. Okay. If I'm just looking within this first, first section then of my tens, how many pieces am I going to shade in? Or in other words, 2/100 in decimal form is written like this: 0.002, or in fraction form, it's written out as 2 as our numerator, 100 as our denominator. If we counted out 100 pieces and we know that we need to shade in just 2 now, we're going to look at these smaller lines, and I'm just going to shade in 1 and 2 pieces. So go ahead and do that too. And now we have shaded in here 6/10. Go ahead and label with me. And then this little part here is 2/100. And then for part B, we're going to put it all together. Why does the drawing show 6/10 plus 2/100 is equal to 60/100 plus 2/100? So what changed here? How are these two numbers related? Well, it depends on the way you look at it. When we were shading in, we were looking at this as 1/10, this as 1/10, this is 1/10, this is 1/10, this is 1/10, and this is 1/10 to reach 6/10. You can also view it as this. If we wanted to, we could have counted out 60 of these smaller little pieces. And we could have been really, really precise with our shading in. 60 total pieces out of 100 pieces is equal to 60/100. Okay? What this tells me is that these two numbers are, in fact, equivalent decimals. They're written a little differently, and hopefully you'll notice 6/10 is in fact equal to 60/100. They're just written a little differently, and when we're using a model, they look a little different. I'm looking at that as 6/10 pieces, and I'm looking this as 60/100 pieces. Okay, what do you notice about these two numbers? How are they similar and how are they the same? Or sorry, how are they similar and how are they different? Well, they have a 6 in the tens place. Did you notice that? What's different about these numbers? 60/100 has a 0 at the end of it. 6/10 does not. It just ends right there. And we'll talk a little bit about that pattern if we see that in other instances within our problems, okay? So that's number 1. Let's keep going. Number 2 says the number line below is labeled in tenths from 0 to 1. So take a look at the number line. I see that my 0 starts over here, goes all the way to 1 whole. I see that it's broken up into smaller pieces with labels at the bottom. So take a look at those. And let's see what A says. It says begin at 0 and circle a distance to show 28/100 is equal to 2/10 plus 8/100, which is equal to 20/100 plus 8/100. Woo, that's a mouthful. Well, let's just start off with the first number, 28/100. And what they said is they kind of just broke it up into expanded form. We know that 28/100, if I break apart these digits with their place values, is equal to 2/10 plus 8/100. So let's just start with that. Let's start first with 2/10, and we're going to be doing circles. And I like to do tenth by tenth, okay? So from 0 to 1/10, we're going to circle that. That represents 1/10. And from 1/10 to 2/10, I'm going to do another circle. And now on my number line, I have 2/10 circled so far. So that part's done. And let's work with 8/100. How can I circle 8/100 within this number line? We're going to have to do some cutting up of pieces here, okay? Take a look at this piece, 2/10 to 3/10. I can break this piece apart even further to represent hundredths, okay? So I'm going to look at this 1/10 here, okay? And I can look at it like money. In currency, 1/10 is equal to what? 1/10 of a dollar? What kind of coin are we thinking of? A dime. 1/10 of a dollar can be represented as a dime. I want to exchange this dime in. I want to cut it up into smaller increments, and I want to show hundredths. What currency do we use to represent hundredths of a dollar? Pennies. Okay. And I'm going to split it up into how many pennies is equal to 1 dime. How many pennies are there in 1 dime? 10. So what I'm going to do is I'm going to exchange my 1 dime for 10 pennies. Or in other words, in number line form, I'm going to take my 1/10 and I'm going to split it up into 10 other pieces. And my pen is really too thick for this. So with your pencil, carefully between 2/10 and 3/10, split your 10th into 10 pieces. Oh. And now we're going to keep circling to represent 8 hundredths. Out of these 10 hundredths that we just drew out, how many hundredths are we going to circle? 8. So carefully count out to 8. And there we go. Okay, and let's label. I just shaded in 2/10 and 8 hundredths. Okay, and then it also said that we should be realizing now that it is in fact 2/10 is equal to 20 hundredths. It's kind of like what I just said. So if I took 2 dimes and I exchanged it for pennies, how many pennies would I have? 20 pennies. Okay, all I did was add a 0 there. Different currency, so different coins, different amount of coins, but same value in terms of money and in terms of value. Okay, so 2 dimes is in fact equal to 20 pennies. It's just written differently, and it's definitely shown differently too. Okay, and now it says part B says circle a new distance to show 74 hundredths is equal to 7/10 plus 4 hundredths plus 70 hundredths plus 4 hundredths. Okay, well, I'm going to change colors for mine. You, of course, can't with your pencil, so just follow along with me. Let's just start off with that 7/10. How can I draw a new circle here? Just pretend like this doesn't exist in your number line anymore. We're going to create a new distance. How can I circle within this number line to represent 7/10? I'm going to start over here, my 0. I'm going to do one larger circle all the way to 7/10. Go ahead and do the same. Let's label that. That was 7/10. How do we represent 4 hundredths? Well, we're going to follow the same procedure over here. Go ahead and try it. Between 7/10 and 7/10 and 8/10, what are we going to do? We're going to split up into 10 pieces. Go ahead and quickly do that. And then we're going to circle out of 10 pieces. We're going to circle a total of 4. 4 hundredths. Okay, and then take a look back at your work. Does it look good? Great, let's keep moving on. All right, number 3 says shade the grids to represent each amount. Let's take a look at A. How do you say this number out loud? 4/10 is equal to, how do you say this number out loud? 40 hundredths, okay? And then we have that equal sign in the middle of them to represent that these are 2 different decimals written 2 different ways, but they are in fact equal to each other. And we're gonna represent that in this grid. Take a look at this first grid. How many pieces is this grid split up into? How many pieces? Go ahead and try and figure it out. We're going to look at this grid as if it's one whole. How many pieces is this one whole split up into? Well, you should have maybe counted across first and noticed that there was 10 pieces to cross, 10 pieces down. 10 times 10 gives us a total of 100 pieces. 100 pieces is what this one whole split up into. And we can represent these 2 numbers 2 different ways, and they will equal, in fact, the same amount. So 40 hundredths, remember the fraction that goes along with 40 hundredths, if I were to rewrite it as a fraction, would be 40 as my numerator, 100 as my denominator. So 10 total pieces, 40 to shade in. Wow. So that means we would go box by box, shading in, counting each one out, 40 total different pieces. Okay? That's one way of doing it. I actually don't want you to do that just yet. Let's work with 4/10 first. 4/10 as a fraction is written like that. Okay, and you can view this grid a few different ways. You can look at it with the vertical lines or the horizontal lines. I'm going to just look at it with the vertical lines. And do you notice when we were counting out how many pieces there were, my strategy was just to count across and then count down. And then I noticed that there was 10 pieces across, 10 pieces down to represent 100. So what if we viewed it this way? If I said, this is one piece, this is one piece, and so on. Let's go ahead and break those apart. And let's ignore those horizontal lines for a moment. Let's ignore the horizontal lines and let's just look at it almost, I know that's kind of confusing, almost as if those horizontal lines don't exist and that we just have 10 pieces across, okay? And I would tell myself if this is equal to one whole and there's 10 total pieces, I can look at it like this. And if I'm looking for 4/10, how many total pieces would I be shading? 4. Okay, so carefully, I know mine is probably going to be much more um, messy than yours. Carefully shade in 1 piece, 2 piece, 3 pieces, 4 pieces. 4 pieces out of a total of what we ignored was 10. And is this true? Did we also represent 40 hundredths? Quickly count them out. Yeah, there's 10 here, so that's 10 pieces, 20, 30, 40 pieces. Different decimals, they are equivalent though, and we just proved it in this grid. Let's keep proving on this one. For B, 36 hundredths is equal to 3/10 plus 6 hundredths. Let's use the same strategy that we just did. Let's ignore these vertical lines. Let's just pretend like this one whole has 10 pieces. Mine's really messy, to represent 3/10. So let's shade in 1 piece, 2 pieces, 3 pieces. I use my vertical lines, 1, 2, 3 pieces shaded in. That's also representative of 30 hundredths, 30 pieces. Okay, and then what about the 6 hundredths? How many boxes am I going to shade in? There, it's the same grid. There's still 100 pieces. How many pieces am I going to shade in to represent 6 hundredths? Well, what would be our numerator here? 6. So I'm just going to do 1, 2, 3, 4, 5, 6. Does yours look like mine? Something similar? Great. And then let's take a look at C. How do you say this number out loud? Go ahead and try it. 1/1000. Okay. And if I were to write that out as a fraction, I'm running out of space, it would be 1/1000. 1 would be our numerator, 1,000 would be our denominator. But this is only split up into 100 pieces still. I don't have 1,000 pieces here. Well, how can I represent 1/1000 here? What we're going to do is we're going to take one of these boxes, any box. I'm going to use just this lower one right here. What we could do if we wanted to form 1,000 pieces out of this whole grid, we would take each box and we could kind of zoom into it. How many pieces would I be tearing this little part into or breaking this part up into to represent um, how we're going to be forming 1,000 out of these? Well, think of it like in money ways. Remember, we're exchanging. If this was 1 penny and I wanted to be talking about 1,000th of a dollar, we were talking about splitting up the penny up into how many total pieces? 10. And again, mine's much more messy. Go ahead and do what I'm doing. Take the one box, draw a new model underneath here, draw a box and split it up into 10 pieces. And how many pieces am I going to shade in? Well, just one. So this is 1 piece shaded in out of a total of 1/10. And if I were to do that for each of these boxes, I'd take each box and split it up into 10 pieces. And when I did that with 100 pieces, which we're not going to do, we would have a total of 1,000 pieces and 1 piece shaded in. Okay, great. I know mine's a little messy, but yours should be looking pretty similar to mine, just a little neater. And then let's take a look at number 4. It says, use a sketch of money. a bar representing one whole, a number line, or one or more grids to prove that each statement is true. And for A, we have 3/10 is equal to 30 hundredths. Let's use the strategy of sketching money here. So over on the side, go ahead and write out the number 3/10. How do we represent 3/10 with money? What currency should we be doing? 3's in the 10th spot. What do you think of when we're thinking about tenths? Dimes. How many dimes are equal to 3/10? 3. So what I'd like you to do, just quickly draw out 3 dimes. I'm going to put little d's in the middle. I want you to do the same. 1 dime, 2 dime, 3 dime. That represents 1/10. Sorry, 3/10. And let's take a look at this 30 hundredths. Well, if I was exchanging a dollar bill for pennies, how many pennies would I have to equal 30 cents? How many pennies? 30. So I'm going to draw 1 dime with the letter P in it. I want you to do the same. For time-wise, let's not draw 30 exactly like this. Let's just do 30 dots now. So 1, I have 30 dots. Do you have 30 dots? All those 30 dots represent pennies. Is this true? If I were to say I have 3 dimes and I also have 30 pennies, are those the same? Are they equal to each other? Okay, let's say you go into a store and you want to purchase something that costs 30 cents and you hand the cashier 3 dimes. And let's say you go back the next day and you want to buy the same thing. And instead of handing them 3 dimes this day, you're going to hand them 30 pennies. Does that work? Is that equal to each other? Yes. 30 dimes, sorry, I'm getting tongue tied here. 3 dimes is in fact equal to 30 pennies. This is equivalent. Okay. And then 70 hundredths is equal to 7/10. Or sorry, 70 hundredths. I'm getting confused here. Let me start over. B. 70 thousandths is equal to 7 hundredths. Is this true? Boys and girls, we're not going to actually draw a model really quick for this one. I'm running out of time in this video, but here's what I want you to do. Let's relate this one to number 5. Equivalent decimals. Why does writing zeros to the right of a decimal number not change the value of the number? Here's the rule that goes along with writing decimals, and you've hopefully started to catch on as we did these exercises. The rule with decimals is if you add zeros after the decimal, after whatever digit is within this number, it does not change the value of the number. Okay? If you add zeros to the right of a decimal after the digits, it does not change the value of the number. So if I rewrote 7 hundredths here, if I add this 0, does it change the value? And the answer is no. I could continue writing zeros and zeros and zeros. It doesn't change the value. Okay? So for example, 1/10 or 1 dime, if I were to add in a 0, basically what that shows me in monetary way is that I'm exchanging a dime for 10 pennies. Is a dime and 10 pennies the same in value? Yes, they're both equal to 10 cents. And if I were continuing with my zeros, it doesn't change the value of this 1/10. Okay? And this is a special rule that only goes along with decimals. This does not work for whole numbers. So, for example, if I have $10 and I'm going to add zeros to it, is $10 the same as, if I add 2 zeros, the same as $1,000? No, this does not work for whole numbers. This rule only works for decimals and adding zeros at the end of your digits. Okay? Let's go ahead and flip to the next page and keep this rule in mind. Okay, and then on the next page, on page 44, I'm going to read the heading out loud. It says practice comparisons. Please follow along with me reading this out loud in your book. It says we can use secret code cards to compare decimal numbers. For example, these cards show that 4/10 is greater than 9/100 and 9/100 is greater than 7/10. So remember with your secret code cards, any cards that are in green represent numbers that are decimals or are numbers that are less than 1. And when you flip those secret code cards on the back, they either have dimes, pennies, or tenths of pennies drawn out on the back of the secret code cards. So, for example, for tenths, if you were to flip this card over, you would have a picture of 4 dimes. And for 9/100, if you were to flip this card over, it would have a picture of 9 pennies. And for 7,000s, you would have a picture of 7/10 of a penny. Remember, we don't have currency that goes along with thousands place value. What we're picturing is a penny split up into 10 pieces. And for 7,000s, it would be 7 little pieces of 1 penny. And again, you would need 3 more to form 1 full penny or 1 cent. Okay. And then it says we can also use dimes to represent tenths and pennies to represent hundreds to show that the value of a dime is greater than the value of a penny, and the value of a penny is greater than the value of a tenth of a penny. Okay, and then it says choose any method and use it to complete the following comparisons. Write greater than, less than, or equal to. And we practice these comparison symbols in our fraction unit. Remember, you want the comparison symbol open towards the number that is greater in value or has a greater amount to it. And think of an alligator. Okay, so we're going to be looking at these comparison symbols again. Let's just take a look. And here's the thing with the secret code cards. They are a great tool to use, but they have some drawbacks to them. It's a lot of sorting and it's a lot of time put in to be finding each of these digits within your comparison, within your secret code cards. So we're going to use them a little, but the best tool that I would like to focus on when we're comparing decimals is our place value chart. So go ahead and get your place value chart ready. And here's what I'd like you to do at the top. Above the tenths, what I'd like you to draw a picture of is a dime. And how I want you to do that, just put a circle and a D for dime. Under the hundreds, I'd like you to draw another coin and put a P for penny. And for thousands, I want you to just draw a little tenth of a penny. It looks almost like a little pizza piece. And remember, how many thousandths equals 1/100th? 10 of them. Okay, so 1,000th of a dollar or 10,000ths of a dollar is equal to 1 penny. We need 10 of these little pieces to reach 100. Okay, so does yours look like mine? I want you to keep those drawings on your place value chart for the rest of this lesson. So as you go back to your live Zoom times, you're going to have these pictures up here and that will guide you to these questions, okay? So I'm going to keep that there. I'm going to go back to your activity book. Let's work on number 7 really quick. 7,000ths compared to 7/10. Here's how we're going to solve. We are going to insert both of those numbers into our place value chart. So I'm going to start off with the 7,000ths. And if I were to write 7,000ths in my place value chart, I would add in my zeros and make sure my sevens is in the correct place value of the thousands. And it was 7,000ths compared to 7/10, okay? And then we're going to write in 7/10 on the next line. And here's what it looks like, my sevens in my 10th spot. And here's the questions that we're going to ask ourselves in determining which one is greater. Okay. So for this one, I have no ones, I have no dimes, I have no pennies. I have 7 pieces of a penny in which I need 10 of them to reach 1 cent in value. So this represents 7,000ths or 7 tenths of a penny. 7/10 now down here represents as if I were to have 7 dimes. So which one is bigger in value? Which one is greater? 7/10, okay? 7 dimes is definitely greater in value compared to 7/10 of a dollar. So what I'd like you to do for each of these problems is I want you to keep in mind that I want you to go place value by place value and ask yourself is relate these digits and these place values back to money. Okay, so let's add in that answer for that was number, I forget. Hold on one second. Let me erase. That was number 9. 7/10 is greater than 700ths. And then let's go back to number 6. 7/10 compared to 700,000ths. Okay, let's go to our place value chart and let's add in those two values. 7/10 compared to 7,000ths. Does your place value chart look like mine? Remember what the rule is we can continue adding zeros at the end of decimal digits and it won't change their value. So oftentimes when I see that two numbers have place values that end differently, so this one stops at tenths and this one stops in thousands, I add in zeros just for my own visualization, just so that they all end in the same place value. So if I add in the two zeros, I didn't change anything about the value of the number. I'm just ending at the correct spot that this one's at. So now I had 7/10 compared to 700ths. Now I have the same number. What does that tell me about these numbers? Well, let's relate it back to money first. 7/10 would be as if I would have 7 dimes. And 7,000 would be as if I had 7,000 of of tenths of a penny. And if I put all those 700 tenths of a penny together, I would get 70 pennies. And 70 pennies is in fact equal to 7 dimes. These numbers are equivalent. They are equal in value. They look different at the beginning. So let's go back to that page. They looked different in the beginning, but they are in fact equivalent. Let's put an equal sign in for number 6. And we're going to keep on continuing this in your live session. So please don't work ahead at all. Go ahead and keep that as is and pause the video and you'll continue in your live Zoom.